Chem 6BL student. I don't know about you, but steak is my favorite food. So today I want to explore the chemistry and teach you what makes steak taste so good to me. And so how does a steak go from looking like this to looking like this? The answer is the Maillard reaction. So the Maillard reaction is not only responsible for the great flavors that we taste in steak, but it's also in many other foods. Pretty much any time we cook a food and it browns and it gets brown on it, then that's the Maillard reaction. So this happens when you are toasting bread, when you make cookies, when you roast coffee, anything like that. That's the Maillard reaction in action. And so the basic scheme of the Maillard reaction is it's a reaction between amino acids and reducing sugars within the meat or whatever you're cooking. And this leads to a huge variety, a cascade of reactions that happen. And it ultimately creates a bunch of aromatic compounds that make up all the scents and tastes that we love in a steak and in other foods like that. And it also, so it makes aromatic compounds, and then it also makes melanoidins, which are responsible for the browning color. And so here's a couple examples of some of the aromatic compounds that we see. Alkyl pyrazines give foods cocoa or nutty roasted flavors, so that's often found in things like coffee beans. Caramel-like pheromones are found in bread. Thiopenes, this is what I really enjoy. That's the meaty flavor that's found in meats like steak. And then oxazoles often give a sweet taste. And then other compounds, such as allopuridine, can just enhance flavors. So it makes anything sweeter, anything that's sweet, more sweet, anything salty, more salty. And then acrylamines are formed when the heat is too high, and those are carcinogens, and so that can also be formed from this reaction. So there are two aspects to the Maillard reaction that are very important to give you the tasty flavor that you desire. The first is energy supplied in the form of heat, and then the second is that it's done in dry conditions. The Maillard reaction can happen if there's not a lot of heat provided, but it just happens a lot slower and doesn't taste nearly as good. So you want it to be in the range of about 230 to 340 degrees Fahrenheit in order to get the best results from the Maillard reaction. This, if you heat it like this, then it allows for the long chain amino acids and sugars to degrade down into smaller, and it also promotes more interactions between the molecules so that they're able to react. And then the reason that you want it to be dry is because boiling water cannot go above 212 degrees. So if you boil meat, you get like a gross gray color. But if you have dry conditions, so where the pan meets the meat, and that's a dry surface, then the water's gone and you can get it up to a much higher heat, up to like 300 degrees where the Maillard reaction happens in the best conditions. And that's why the middle of the steak doesn't brown, because the inside can't go above 212 degrees. And so this is kind of how we get that surface very hot in between the meats, and so this is how we get the best results from the Maillard reaction. Also, while I'm doing this reaction, I will be using a cast iron skillet, a New York steak, salt and pepper and butter only for flavor. So those aren't really participating in the reaction, but it's going to be super tasty, and I'm super excited to show you guys. Alright, so here we have our steak that we're gonna grill. It's cooking the cast iron pan. We have it right here. It's already hot with some oil. And so it's a New York steak. And remember how I said it has to be dry, so we're gonna dry it one last time before we put it on. Let's do that. And then we're gonna throw on some salt. And then just put it on down. There we go. Salt the other side. And let the reaction happen. Alright, so as I mentioned, the Maillard reaction has a cascade of different reactions, but it all starts right here, where with a condensation reaction where the nucleophilic amino acid attacks the electrophilic carbonyl group of the reducing sugar. And so this loses water and it forms a glycosylamine. And so then this glycosylamine can undergo a sort of tautomerization reaction where it forms an enamine, and then it further forms into a ketosamine, or in the case of the Maillard reaction, they often call it an amidori compound. Now this amidori compound then has options to go to, and it can then further go, it can be dehydrated and then deaminated into a dark dicarbonyl group. And this dicarbonyl group is really the compound that can undergo many different reactions to create all the different aromatic compounds that I already talked about. But it can also go forward to create aldehydes, which also provide a lot of flavor. And these carbonyl groups are very electrophilic, so they are susceptible to nucleophilic addition and attack to make many different compounds. But what these dicarbonyl groups often do is they react with more amino acids in the meat, and ones that were lost right here, and they do Strecker degradation. And this is the mechanism for that. So these two react to form these compounds. Water's lost. We see the arrow pushing all the way through, and it ends up forming a Strecker aldehyde, which is an aldehyde, and a lot of these aldehydes also provide many of the great flavors in meats and in other foods that we taste and we enjoy so much. So as you can see, there's a lot of different reactions going on, but they all build on each other and branch off of each other to make many different compounds. Just to give you guys a little bit more about the specifics of the reaction, different amino acid compositions in food have different effects. So valine is common in bread. Phenylalanine gives floral smells and flavors. Glutamic acid gives popcorn its taste. Lysine has 2 amino groups rather than 1 like most of the others, so it has more binding sites for the reducing sugars to undergo that reaction. So therefore, it reacts the fastest and forms the darkest colors. Additionally, you can increase the pH by adding a base, and this will speed up the reaction. This is because the base deprotonates the amino group, making it more nucleophilic. So now, while the steak is cooking, we can look at an example of this with onions. Onions are cool because they undergo both the Maillard reaction and caramelization, which is the other form of non-enzymatic browning. But caramelization happens when 2 sugars react with each other. So we are going to still see the effects of a base on the Maillard reaction. So what I've done here is I've cut up onions, and I have 2 pans at equivalent heat with the same amount of oil, and I'm going to add the onions into them. And the only difference between the 2 is one of them I'm adding baking soda to, which is the base, which should deprotonate it, the amino group, and make it more nucleophilic, so the Maillard reaction should happen faster. Let's see the results. We see that the onions that were base catalyzed are more brown, meaning that the Maillard reaction happened faster. The Maillard reaction can also be increased by higher concentrations of sugars and amino acids. So we've now been letting this side cook for about 4 minutes. We're getting ready to flip it. I'm going to wait to add the pepper until it's flipped, because pepper tends to burn at high heat. So let's see that Maillard reaction in action. Look at, to see all this browning, that's all the Maillard reaction working. Alright, so here's our finished product. We have our steak, and look at all that browning on there. That's all from the Maillard reaction between the amino acids and the sugars, and for all those different reactions that I already talked about. But that is what creates all those tasty flavors that we love and smell. One of my favorite foods is steak. And it really wasn't that difficult. So this was a really awesome experience for me to try to show you the chemistry that happens in a steak, and just a little fun thing to do in the kitchen during quarantine. So here's my steak. I hope that you can try this and now you understand it. Thank you very much.